So then let's take this square root of 75x squared and separate it into two radicals, one containing perfect square factors and one containing factors which are not perfect squares. We know that 75 has, again, 25 as a factor, and 25 times 3 gives us that 75. And then if we look at the variable portion, x squared is a perfect square, and we would leave no variable under this radical at all. So now let's take this out of the radical because both of these are perfect squares. We can say that this is 5x times the square root of 3. Okay. So just for kicks and giggles, what happens if, this is not on your note sheet, but what happens if we have the square root of x to the third? That's something worth talking about. If I break this into perfect square and non-perfect square factors, a perfect square factor would be x squared. A non-perfect square factor would be x. And then I can take this out of the radical. I'd have x times the square root of x. Okay, and which is perfectly fine to have. You can have one in and one out of the radical. Okay, so how do you add and subtract radicals? Well, they're kind of cliquish. They only like to be added and subtracted if they are the same type. It's kind of like adding or combining like terms. You can only combine square roots if they have the same radicand. Okay, and what is a radicand? A radicand is just a fancy name for what is underneath the square root symbol. So in this case, 3x is the radicand. Okay, so if we start with something very, very simple, we could look at 7 times the square root of 17 plus 19 times the square root of 17. I've got 7 of this rad 17, and I'm adding it to 19 of the square root of 17. Then I can just add what's on the outside and keep the radical. So this would be 26 of that radical 17. It's kind of like if you had 7x plus 19x, you would end up with 26x. This is just kind of taking the place of that variable. So what happens if we've got then the square root of 17x minus 20 times the square root of 17x? Well, we do have the same radicand. We can combine them into a single term. Well, what's outside of this? Outside of this, we have this implied 1. So we've got really 1 minus 20 of this radical 17x. So we end up with negative 19 times the square root of 17x. Okay, and one last one of these. Let's look at 7 times the radical 3 plus square root of 12. Well, if we look at this initially, the radicands are not the same. So at first glance, it looks like we cannot combine these two radicals, but this radical is not simplified. So we need to think about it in its simplified form because that may be different. Well, the square root of 12, that breaks into a perfect square factor and a non-perfect square factor. That perfect square factor is 4. The non-perfect square factor is 3. Take this out of the radical and this becomes 2 times the square root of 3, which now we can add to 7 times the square root of 3. 7 of these plus 2 of these, that gives me 9 of those things, those square roots of 3, and we are good to go. Last topic for this video is how do you rationalize the denominator? And what do we mean by that? Well, there's this kind of unspoken rule with radicals that we cannot have radicals in the denominator. So no radicals in the denominator. They can occur in the numerator, that's fine, but not the denominator. So there's two techniques to rationalize a denominator. One is if the radical contains only one term, And the other one is if the radical contains more than one term. Okay, so we're going to look at, actually the denominator contains more than one term. So if the denominator only has one term, we multiply the numerator and the denominator by the radical. Okay, so if it has one term, multiply the numerator and the denominator by the square root. Whatever that square root is that's in the denominator. Okay, so something like that. So in your examples in A, we have 15 over the square root of 6. Okay, so we would multiply the numerator and the denominator by that square root of 6. All right, and so we end up with 15 times the square root of 6 all over the square root of 6 times the square root of 6, which is otherwise known as the square root of 6 squared. So we can just remove the radical. Okay, because when you're squaring a square root, you're undoing it. So this is our answer, but this fraction here is not simplified. So we want to take that 15 divided by 6 and take out the common factor of 3, which is 5 over 2, and keep that radical 6 where it was. Okay, so that would be example number 1. Example number 2 is B, and we've got 6 over the square root of 12. Well, there's kind of two ways you could do this. You could simplify this and then rationalize it, or you can rationalize it first and then simplify it, and it doesn't really matter. Whatever floats your boat. I'm going to go ahead and simplify it first. And we know from a previous dialogue we had that the square root of 12 is equivalent to 2 radical 3. Okay, so now I can take this and take that 6 over 2, right? 6 over 2 is otherwise known as, this is equal to, this is otherwise known as 3 over 1. So we can have this be 3 times the square root of 3. Well, we still have this radical in the denominator, so we need to multiply top and bottom by the square root of 3. So we have 3 over the square root of 3 times the square root of 3 over the square root of 3, which is 3 times the square root of 3 all over the square root of 3 times the square root of 3, which is the square root of 9, which is just 3. Or we talked about it earlier, the square root of 3 squared. That squaring undoes the square root. And now I have 3 over 3. Those cancel, and I'm left with just the square root of 3. Okay, so the last thing that we want to look at is how do you rationalize the denominator when you've got multiple terms? Well, that is a little bit trickier, okay? So we're going to multiply the top and the bottom by the conjugate of the denominator. The conjugate is, if I have A plus radical B, the conjugate would be A minus radical B. And vice versa. If I had A minus radical B, then the conjugate would be A plus radical B. Okay, and we do that because by multiplying that A plus B times A minus B, we get A squared minus B squared, and that gives us a whole number and no radicals anymore. So we're going to multiply this by the conjugate. So 4 minus the square root of 5. 4 minus the square root of 5. Okay, so we're going to take that top, and it's going to look like this. 8 times 4 minus the square root of 5. We're going to take the bottom, and that's going to be 4 plus radical 5 times 4 minus radical 5. Okay, so let's distribute the top. 8 times 4 gives us 32. Oops, sorry, 32 minus 8 radical 5. Fine. And then on the bottom, we have A plus B times a minus b. If you see that pattern, you can just jump to a squared minus b squared. So a being 4, that would be 16 minus b squared. The square root of 5 squared would be 5. So now we've got 32 minus 8 radical 5 all over 11. And you see there's no radicals in the denominator anymore, and this is fine. So that's all she wrote on review of radicals. We'll pick up with complex numbers the next time we meet. See you then. Bye-bye.